The modern periodic table. Modern periodic table states that properties of elements are a periodic function of their atomic number. Course of periodicity. The course of periodicity in properties is the repetition of similar outer electronic configuration after certain regular intervals. When elements are placed in the order of their increasing atomic number in the periodic table, the elements having the same number of valence shell electrons is repeated in such a way so as to fall under the same group. Valence shell electrons are the electrons present in the outermost shell of the element. Modern periodic table is based on the electronic configuration of the elements. Atoms of every element has specific atomic number and the electrons remain distributed in different shells like K, L, M and N as per of-Bohr's rules. We will discuss it briefly. In simple words, as per this rule, electrons are filled in various shells as per 2n² formula. Here, by placing value of n, we can detect the number of electrons in various shells. It also helps us to write electronic configuration of the elements. Of-Bohr's rules. 2n². n equals 1. 2 into 1 square equals 2. n equals 2. Then as per of-Bohr's rule, 2 into 2 square is equal to 8. n equal to 3, then 2 into 3 square is equal to 18. By putting value of n as 1 in this formula, we get 2 into 1 square is equal to 2. This is the maximum number of electrons in the K shell. By putting value of n as 2 in this formula, we get 2 into 2 square is equal to 8. This is the maximum number of electrons in the L shell. By putting value of n as 3 in this formula, we get 2 into 3 square is equal to 18. This is the maximum number of electrons in the M shell. Number of electrons in the valence shell of an atom is responsible for the chemical properties of an element. The chemical properties of an element are determined largely by the electrons in its outermost or valence shell. If we look at the periodic table in group 1, we find that sodium and potassium are having similar chemical properties. Let us now learn about long form of periodic table, which is widely used nowadays. In this table, elements are placed in the increasing order of their atomic numbers. It consists of horizontal rows and vertical columns. This is also called Bohr's table since it also follows Bohr's scheme for the arrangement of various electrons around the nucleus. Each vertical column is known as group, and each horizontal column is known as period. Let's discuss them one by one. The long form of periodic table consists of 18 vertical columns or groups. These are denoted as 1A, 2A, 3A, 4A, 5A, 6A, 7A, A3 columns, 1b, 2b, 3b, 4b, 5b, 6b, 7b, and 0. Group number of each group is mentioned above it. Each group consists of a number of elements having the same electronic configuration in the outermost shell or valence shell. On moving down the group, the number of shells in the elements increases, but the number of electrons in the valence shell remains the same. Elements in the same group have the same number of valence electrons. That's the reason that they show same chemical properties. The long form of periodic table consists of 7 periods. In a period, the elements are placed with consecutive atomic numbers irrespective of the length of the period. The first period has 2 elements, hydrogen and helium. It is known as very short period. The second and third period has 8 elements each. These are known as short periods. The fourth and fifth period has 18 elements each. These are known as long periods. The sixth period has 32 elements. It is known as very long period. The seventh period is incomplete. 14 elements of sixth period are known as lanthanoids, and 14 elements of seventh period are known as actinoids. Lanthanoids and actinoids are placed at the bottom of the periodic table. Characteristics of S-block elements. The elements in which the last electron enters the s orbital of their respective outermost shells are called S-block elements. They are soft metals. They have low melting and boiling points. They lose the valence electron to form monopositive and dipositive ions. They are very reactive metals. Reactivity increases as we move down the group. The compounds of S-block elements are ionic. They also impart colors to the flame. They are good conductors of heat and electricity. Characteristics of p-block elements. The element in which the last electron enters the p orbital of their respective outermost shells are called p-block elements. It includes both metals and non-metals. The metallic character increases from top to bottom within a group. The non-metallic character increases from left to right along a period. They form covalent compounds having more than one oxidation states. Oxidizing character increases from left to right. Reducing character increases from top to bottom in a group. Characteristics of d-block elements. The elements in which the last electron enters the d orbital of their respective outermost shells are called d-block elements. They are hard, malleable, and ductile. They are good conductors of heat and electricity. They form both ionic as well as covalent compounds. They show variable oxidation states. They form colored complexes. Most of the transition metals are catalysts. Most of the metals form alloys. Characteristics of F-block elements. The elements in which the last electron enters the f orbital of their respective outermost shells are called F-block elements. These elements form colored salts as their salts absorb light from certain visible wavelengths. Actinides, that is, 5F series, are radioactive elements. F-block elements are metals having high melting and boiling points. General group of elements. In addition to the four groups, the elements are also placed in the periodic table in four general categories. Representative elements. Elements of a group S and P are known as representative elements or normal elements. In these elements, all the inner shells of elements are completely filled with electrons. Outermost shell is incomplete in these elements. Noble gases. Elements of group 18 are known as noble gases, inert gases or rare gases. These are helium, neon, argon, krypton, xenon and radon. These elements have completely filled shells. Helium has 2 electrons in it. Other noble gases except helium have 8 electrons in the outermost shell. Transition elements. D-block elements are also known as transition elements. These are located between S and P block elements in the long form of the periodic table. Outermost shell and next to the outermost shell is incomplete in these elements. Inner transition elements. F-block elements are also known as inner transition elements. These are located at the bottom of the long form of the periodic table. The 14 elements from atomic number 58 to 71 after lanthanum are known as lanthanoids. The 14 elements from atomic number 90 to 103 after actinium are known as actinoids. Position of alkali metals in the long form of periodic table. The group 1 of the periodic table comprises 6 elements: lithium, sodium, potassium, rubidium, cesium and francium. Besides hydrogen, which is not a member of the alkali metal family. It has been included in group 1 because of its similarity with the electronic configuration of these elements. These are called alkali metals since they readily dissolve in water to form soluble hydroxides which are strongly alkaline in nature. All these elements are typically metals. Position of the alkaline earth metals in the long form of periodic table. These elements are located in the second group of the periodic table. The elements of group 2 of the periodic table are beryllium, magnesium, calcium, strontium, barium, and radium. With the exception of beryllium, they are known as alkaline earth metals. Beryllium shows anomalous behavior than the rest of this group. The oxides of these elements are similar to those of alkali metals and dissolve in water to form hydroxides or alkalis. The oxides of calcium, strontium and barium were also quite stable to heat and do not decompose even on strong heating. These metal oxides and their metals are also called alkaline earths. At present, all the elements included in the family are known as alkaline earth metals. Metallic character of alkali metals. Group 1. They have silvery and shiny surfaces. The metallic character further increases down the group. In the alkali metals, the kernels are of large size as it depends upon its atomic size and there is only one valence electron. Therefore, metallic bond is rather weak and as a result, alkali metals are quite soft. They can be cut even with a knife. Lithium, the first element, is the hardest since the kernel is the smallest in size. Reactivity of alkali metals with air and moisture. When the alkali metals are exposed to atmosphere, air and moisture, they get converted into oxides, hydroxides and finally to carbonates. Thus, alkali metals get tarnished. Metal reacts with oxygen to form metal oxides. Metal oxide reacts with water to form metal hydroxides. Metal hydroxides react with carbon dioxide to form metal carbonates and water. Because of this reason, the alkali metals are stored in inert hydrocarbon solvents like petroleum, ether and kerosene oil, which prevent them from coming in contact with air and moisture. Lithium reacts with oxygen to form lithium oxide. Sodium reacts with oxygen to form sodium peroxide. Potassium reacts with oxygen to give potassium superoxide. Rubidium reacts with oxygen to form rubidium superoxide. Cesium reacts with oxygen to form cesium superoxide. Thus, reactivity with oxygen increases from lithium to cesium. The stabilities of these oxides are linked with the relative size of the cations and anions involved and also upon the charges present on them. A smaller cation can stabilize a smaller anion, while a larger cation can stabilize a larger anion. Advantage of modern periodic table. The use of modern periodic table has made the study of chemistry systematic and easy. It serves as a good teaching aid. The properties of an element can be easily estimated by knowing its position in the periodic table. Periodicity in the properties of elements is well explained as electronic configurations of elements are repeated after certain intervals. The types of compounds formed by certain elements can be easily predicted by knowing the position of the elements in the periodic table. elements have been placed into separate blocks like S, P, D and F, and also into 4 different types of elements like representative elements, inert gases, transition elements and inner transition elements.